A warm welcome to another explainer from SciencePunk on the frame budget approach. All right, Season 2. After getting our conceptual toolkit ready in Season 1 and the intermezzo, we are jumping right into the deep end with the first real stress test, quantum measurement. You know, for a century, we've thought the measurement problem is just incredibly hard to solve. But what if the problem is that we're asking the wrong question in the first place? What happens if we actually take the FBA's DNA seriously? You know, discrete state changes, minimal events, and time, not as a background, but as something that emerges from change itself. Okay, let's dive into this.
So let's just put it right out there, right at the start. This is the big, disruptive idea. For nearly 100 years, the smartest minds in physics have been banging their heads against the wall, trying to answer the quantum measurement question. The frame budget approach comes along and suggests, hey, maybe we need to change the question. What if the real mystery isn't in the answer we're looking for, but it's actually baked into the very assumptions we've been using all along?
So, here's the game plan for this explainer. First, we got to give the classical measurement problem a fair shake, really see what all the fuss is about. Then, we're going to look at what the FBA calls a fundamental rupture with that classical way of thinking. After that, we'll unpack the FBA's core concepts, its DNA, if you will. And that's going to let us reframe the whole idea of measurement as a question of access. And finally, we'll see what new kinds of questions that leaves us with.
Okay, first things first. Before we can start tearing the problem apart, we really have to understand it on its own terms. And this is the mystery. This is the puzzle at the very heart of quantum mechanics that has launched 1,000 different interpretations.
This slide right here, this gets to the deep, almost schizophrenic contradiction in quantum mechanics. On one hand, when we're not looking, right, the system is described as this beautiful, smooth, evolving wave of possibilities. It's all potential outcomes existing at once. It's elegant, it's continuous. But the absolute second we try to measure it, bam, the story completely changes. That whole smooth wave just vanishes, and we're left with one and only one concrete result.
And, well, this is the question that has basically haunted physics ever since. How does nature choose? What physical process is responsible for that sudden, abrupt collapse from this ghostly wave of maybes into a single solid is? Is it us, the observer? Is it the measuring device? Is it something else entirely? That right there is the classical measurement problem.
Okay, so here's where the FBA makes its move. And it isn't to just offer up yet another answer to that same old question. No, it's way more radical than that. It suggests that the very ground on which we're asking the question might be flawed from the get-go.
And this just perfectly illustrates that massive divide. The classical view just kind of assumes, without even thinking about it, that reality is like a movie, right? It's unfolding in this smooth, continuous river of time. And in that movie, the wave function is a fundamental character. But the FBA, it starts somewhere completely different. It says, hold on, reality is actually more like a comic book. It's built from a sequence of distinct frames, these discrete update steps. And time? Time isn't the container that reality happens in. Time is just the ordering of those changes. And that wave? It might not be a fundamental character at all.
So if we're going to get the FBA's take on measurement, we need to really quickly get our hands on its basic building blocks, its fundamental DNA.
So first up, just forget about smooth, continuous change. In the FBA, the world updates in these discrete clicks. A minimal event is literally the smallest possible change that a system can even register. It's not some gradual shift. It is the fundamental tick of reality's clock. It's the jump from one distinct frame to the very next one. And once you have that idea of discrete clicks, the famous wave function gets a radical facelift. It's no longer some fundamental, ghostly entity. Instead, think about it like this. Imagine you're taking a photograph with a really slow shutter speed. Any object that moves is going to appear as a blur, right? Well, the FBA suggests the quantum wave might just be that blur, a statistical picture of tons of tiny discrete events that are happening way too fast or are just too fine for us to pick out individually.
So what governs all these changes? That's where the idea of budget comes in. And it is so critical to understand that this is not a substance. It's not like some cosmic fuel. You should think of it much more like an accounting principle. Every single minimal event, every click of reality, has a cost that has to be paid and accounted for. The FBA, at its heart, is basically a bookkeeping system for reality itself, just tracking how change is conserved.
And finally, we have channels. And again, don't think of a physical pipe. A channel is the actual physical pathway of interaction. For you to even see what's on this screen, photons have to travel from the screen to your eye. That whole pathway is a channel. Information, influence, they don't just magically teleport from one place to another. They have to be mediated through a real, physical structure of access.
Okay, so now we have the tools, right? We have discrete events, we have budget, and we have channels. Let's put them to work and see how they completely transform this measurement problem from some kind of magical collapse into a totally concrete, physical process.
So, in the FBA, what's really happening when we measure something? Well, it's definitely not a passive peek behind some cosmic curtain. No, it's a series of physical events. First, a real interaction, a physical coupling has to happen. Then, we operationally draw a line, a cut, between what we're calling our system and our measuring device. Then, and this is critical, the outcome gets physically recorded, or inscribed, in the state of the device. This is an irreversible step. And what do we see at the end of all that? We only see the slice of reality that was made accessible through that very specific interaction channel.
And this really is the heart of it all. We never ever see the thing in itself. We only ever get to see an operational, visible slice of it. The information we get is defined by and limited by and shaped by the real physical coupling, the protocol we choose to use, and the resolution of our instruments. So what we call a measurement result is simply the information that managed to make it all the way through that entire physical chain of access.
You see the twist now, right? The FBA doesn't lose any sleep trying to explain how some real, fundamental wave magically collapses on itself. It takes a big step back and asks a much tougher question. Are we even sure that this wave, as we thought about it for a century, is the real, fundamental thing we should be starting with? Or is it just a useful illusion, a blurred image of a much deeper, discrete reality?
So you can see this whole perspective doesn't just solve an old problem. In a way, it dissolves parts of it and replaces it with a new and, you could argue, much more productive set of questions to ask.
Okay, so where does all this leave us? Let's boil it down. Takeaway number 1, the measurement problem that has bugged us for 100 years might actually be a ghost, born from these flawed, baked-in assumptions about continuous time and waves. Number 2, the FBA offers a whole new foundation, a world built from discrete, accountable events where time just emerges from the ordering of those events. And number 3, in this world, the mysterious collapse gets totally demystified. It becomes the messy, physical, operational process of accessing a limited but real slice of the world.
Ultimately, the FBA's real win here isn't about giving a final definitive answer. It's about a powerful reframing. It strips away all that excess mystique from the idea of collapse and recasts the whole problem in nuts and bolts physical terms. It becomes a question of access, of system boundaries, and of the irreversible fixation of information. And that is a problem physicists can actually get their hands on.
In our next explainer, we're going to take this new DNA and apply it to another classic puzzle, the tunneling effect. We're going to ask what a barrier is even supposed to be, what's being accounted for there, and why this puzzle, too, totally changes its shape when you look at it through the FBA lens.
So here's a thought to chew on until then. We all think of a barrier as, a solid wall. But if reality is just a series of discrete, budgeted steps, what on earth does a barrier even mean in a world like that? We're going to tackle that next time. Bye for now. Until the next episode, and stay curious.